In this video, we will continue practicing how to graph rational functions such as these. We've already done problem number 1, 2, and 3, which turned out like this. And now we're about to do number 4, which for some reason the number 4 has actually disappeared. But this is number 4, and that's what we're about to do. Alright, so we are being asked to find the x-intercepts. As long as there's no number added on the end, like a +5 or something like that, then what we can do is set the numerator equal to 0. And that's how we can find the x-intercepts. So if I were to set this numerator equal to 0 like this, first thing I would want to do is to factor that thing. So I'm betting it factors. So let's try. Okay, so 2x squared can only factor as 2x times x. 6 could either be 2 times 3 or 1 times 6. I'm going to try the 2 times 3 first, but I know better than to put the 2 here. That would cause a, well, you know what? Let me stop there. I started to say there can be no GCF here inside the parentheses if there's no GCF in the original problem. But then I'm noticing that there is a GCF in the original problem. So that's the first step of factoring, is there's a common factor. All of these are divisible by 2. So before I do anything else, I'm going to pull out the 2. So that's going to leave x squared plus 2x minus 3. So that happened. Now I'm going to go ahead and factor it. I'm going to keep the 2 and do the rest. So looking at this trinomial, x squared can only be x times x. 3 can only be 3 times 1. Now I'm trying to get a positive 2, and I know that inner, inner plus outer equals middle. Inner, I have 3x. Okay, outer, I have 1x. So I'm trying to get positive 2. So if I have a positive 3 and a negative 1, that would make positive 2. So here's my positive 3 and here's my negative 1. And positive 3 times negative 1 makes negative 3, so it works. So now that I have factored it, I can set the numerator equal to 0. The only way that if I set the numerator equal to 0 and solve it, you would solve this by setting these factors equal to 0. You know what I mean? So that would be x plus 3 equals 0 and x minus 1 equals 0. Okay, subtracting 3 from both sides, adding 1 to both sides, that's going to give us x equals negative 3 and x equals positive 1. So that means our x-intercepts are negative 3 comma 0 and 1 comma 0. Alright, for the y-intercept, what you want to do is let x equal 0. Substitute 0 for all the x's. So if I put 0 in for this x right here, that's going to make this entire term 0. If I put 0 in for this x, that means this term is 0. Similarly, this will be 0 and this will be 0. So basically these 4 terms are gone. So that just leaves negative 6 over negative 12, which simplifies to positive 1/2. Okay, so that means that the y-intercept is going to be 0 comma 1/2. Alright, let's go ahead and plot these 3 points that we have so far. Alright, the x-intercepts and the y-intercept look like this. Now let's find the vertical asymptotes. Well, we can find the vertical asymptotes by setting the denominator equal to 0. Alright, so if I'm going to set the denominator equal to 0 and solve, the way I would solve this is by factoring. So I'm going to go ahead and factor the denominator. So this is going to factor as x times x. 12 can either be 3 times 4, or it could be 2 times 6, or it could be 1 times 12. So considering that I want the middle to turn out to be 1, I'm going to go with 3 times 4. Now inner plus outer equals middle. So inner I have 3x, outer I have 4x. To get a positive 1, I need a negative 3 and a positive 4. That would make positive 1. Okay, so here's my negative 3, and here's my positive 4. Okay, also negative 3 times positive 4 is equal to negative 12. So that works out. Now that I have this in factored form, it's easy to see that I need to set x minus 3 equal to 0 and set x plus 4 equal to 0 in order to get my vertical asymptotes. So adding 3 to both sides and subtracting 4 from both sides gives me x equals 3. So that'll be my first vertical asymptote. And x equals negative 4 for the second one. By the way, I'm losing my voice, so I apologize that I'm speaking in such a monotone, like a robot, like a sick robot. But I'm giving her all she's got, Captain. Horizontal asymptotes. As soon as we mention horizontal asymptotes, we have to stop and think. Got to be aware of the degree for horizontal asymptotes. We have to decide which one of these 3 situations we're in. If the numerator degree is less than the denominator, then the horizontal asymptote will be y equals 0. If the numerator degree is equal to the denominator, then you're going to divide the leading coefficients to get the horizontal asymptote. And if the degree of the numerator is greater than the denominator, then there will be no horizontal asymptote. If the degree is exactly 1 greater, then there will be a slant asymptote, but we'll talk about that later. So, what's the situation that we're in? Well, the degree, looking at the numerator, the degree is 2. The degree of the denominator is also 2. It's the highest power. So since the degrees are the same, then we are going to divide the leading coefficients. Now, the leading coefficients are 2 and 1, the invisible 1 here. So that's why the horizontal asymptote will be y equals 2, because this is like y equals 2 over 1, which is the same thing as y equals 2. Alright, so I'm going to graph all 3 of these asymptotes right now, my 2 vertical and my 1 horizontal asymptote. Okay, so here are the vertical asymptotes and the horizontal asymptote. Before we can do anything else, it's time to graph a bunch of points and get a better feel for what this graph is going to look like. Now, as you pick what values you're going to use to graph, and I'm going to record every value we pick on this chart, where you're looking to decide is the vertical asymptotes. And one thing I would urge you to do is always use values that are close to the asymptote for sure. So I need a few values here to the left, I need a few values in the middle, and I need a few values to the right. But the first values I always pick are within decimals of the asymptote on either side. So if my asymptote is at negative 4, if I went a little bit more to the left, that would be negative 4.5. So I definitely want to use that. Let's do negative 4.5. If I went a little bit to the right of the asymptote, that would be negative 3.5. So I definitely want to use that. Okay, look at the other asymptote. This one is at 3. If I went a little bit to the left, that's 2.5. So I definitely want to use that. If If I went a little bit to the right, that's 3.5. I'm definitely going to use that. Okay, I recommend you do the same. Now, I'm going to pick a couple more values over here to the left. So I already did negative 4.5. So I'll go ahead and do negative 5 and negative 6 as well. So I'll do negative 5 and I'll do negative 6. Okay, I need a couple more points in this area. All right, I've got 3 points in here already thanks to my x-intercepts and my y-intercept. I think I'll just do one more. Let's see. I'll see what's happening at negative 2. Take a look at that. Okay, and I'm going to need a couple more points over here on the right. So I already have 3.5. So I'll go ahead and do 4 and 5 as well. So I'm out of space on my chart here, so I'll just add it on the end. Okay, so I'm going to do 4 and 5 as well. Okay, so I'm going to use my calculator to help me find all of these values. Alright, so here's my TI-30XS multi-view. I hit the table button, clear that mess out. I'll go into fraction mode, and let's see, 2x squared plus 4x minus 6. So 2x squared plus 4x minus 6. And x squared plus x minus 12. So that's x squared plus x. Whoa, I'm still in the numerator. My bad. Denominator. So I said x squared plus x minus 12. All right, I'm going to be in ask mode instead of auto. I recommend you do the same. It'll make it easier to find all the decimals that we need. Okay, these are from my previous problem. So I decided I'm going to do negative 4.5, negative 3.5, 2.5, etc. So let's see, negative 4.5. All right, negative 3.5. And what did I say? 2.5. All right, those are my first 3 values. I'll come over here and turn these into decimals using the toggle key. So that's 4.4. All right, so these are all the values that you get. I went ahead and did them all off camera so I wouldn't bore you any more than I have to. So I'm going to take all these values and plot them on the graph and see how they look. I'm going to do all that off camera as well. Alright, here's how those points look. I see that it seems like we're going to have a branch over here approaching the asymptotes like this. This looks like we're going to have sort of this upside down U shape approaching the vertical asymptotes on either side like this. And it appears we'll have a, we'll have a branch over here on the right approaching the asymptotes in this corner like this. Wait a minute, I just realized I made a big mistake with the asymptote here. Why didn't you guys say anything? The horizontal asymptote is not supposed to be at -1. It's at +2. I don't have no idea where the -1 even came from. So I need to move this up to the correct position. Alright, I thought that graph looked a little weird. So this is better. So now I'm going to go ahead and draw the branch that would seem to be about like this. Okay, it's kind of hard for me to draw. We have another branch over here doing something basically like this. All right, and we have a branch this sort of upside down U shape. Alright, doing something like this. Okay, so this is basically what the graph looks like. And if we go to desmos.com and take a look and see, in fact, that's a more professional looking graph. Now, to help me with the range, I'm going to cheat a little bit and tap on this and see that the highest value is about at 0.7. Alright, it's approximately a height of 0.7. So remember that. Okay, so now as we do the domain and we're looking from left to right, the domain is the x values. All the x values are covered except for the vertical asymptotes. So the domain is going to go from negative infinity to -4. Alright, because it has to jump over that asymptote. And we'll pick up on the other side of the asymptote again at -4. Alright, by using round parentheses, we show that the -4 is not actually being included. And this little upside down U part goes from asymptote to asymptote. So that's -4 to +3. Alright, the rest of the number line is covered by this branch right here, which goes from 3 to infinity. So there's the domain. So we have to be a little bit more careful with the range. The range is the y values. We read it from bottom to top. Now, what you have to be careful for is notice that this part of the graph in the middle does not reach all the way up to the asymptote. So it starts down here at negative infinity. So we'll start with that. But then it goes up to some sort of a maximum height. Now, we have a y-intercept here at 1/2. One of our points here at -2. At -2, we're up at 0.6. So you can bet that it's going to be, so we have at least 0.6, but it could be a little bit higher. But remember, we checked Desmos and we found that it actually went just a little bit above that to 0.67. Okay, so we're estimating somewhat, but understand that the range goes from negative infinity to the top of this hump, and that's approximately 0.7, I'll call it. Alright, if this was a test or something, unless you are given access to technology like a graphing calculator, then you will estimate as best you can using the points on your chart. Anyway, there are no points above this upside down curve. There are no points between that and the asymptote. So we'll pick up the range above the asymptote, above the horizontal asymptote, and go from 2 to infinity. Okay, so that's the range. Oh, I made one mistake just now. This 0.7, the top of that little hill, is not an asymptote or anything. This is just a regular point. It's right on the graph. So I shouldn't be using a round parentheses. I should be using a square bracket to show that that point is included in the range. Now, increasing intervals. As I go from left to right across this picture, part of the time I'm rising and part of the time I am falling. So anytime I'm rising will be an increasing interval. So from left to right, this first branch is rising. Alright, so that's an increasing interval right there. Now, looking at this part of the graph, as I pick up here on the other side of -4, I am rising, okay, up to a point. Alright, I'm rising up to about there. Alright, and then I start falling. So I'm going to be falling from here down. So that's a decreasing interval. Okay, and also I'll be falling from here on. Now, when we do increasing and decreasing intervals, we are only talking about x values. So you have to be really careful to only mention x values. So over here on this end, this is an x value of negative infinity. Now, okay, if I draw an arrow right here, don't say positive infinity. The x value is the asymptote, which is negative 4. Okay, now same thing down here. If I draw this arrow, don't think negative infinity. The x value is negative 4. Okay, now this x value right here is tricky because we have to estimate. Okay, it appears to be, I'd say approximately negative 1. So we'd have to give you some leeway, and give you anything that was close, unless we give you access to a graphing calculator or some other kind of technology. Now I'm going to cheat again and look at Desmos and see that it is exactly negative 1.25 is the high point here. So I'm going to use that because it's the true x value. Okay, so negative 1.25. So back to this, the asymptote here is at 3, and this end also the asymptote is at 3. That's the x value of this arrow. The x value of this arrow is positive infinity. So my increasing intervals, my first one goes from negative infinity to negative 4. Okay, so I've got negative infinity to negative 4. But then I've got another one that goes from negative 4 to negative 1.25. Okay, now I've got these pink zones, which are the decreasing intervals. And they go from, this first one goes from negative 1.25 to 3. Okay, and my last decreasing interval goes from 3 to infinity. Notice how I'm using only round parentheses, no square brackets, even on the numbers. Okay, even on the 1.25. Clearly I won't use any square brackets on asymptotes because you never reach them. But the reason why I don't use a square bracket on the negative 1.25 is because it's increasing on its way to this point, and it's decreasing on its way out. But right at negative 1.25, it is neither increasing nor decreasing. It's neither going uphill nor downhill. It's in perfect balance. It is flat for one instant. Okay, so I will show that it is not included by always using round parentheses for increasing and decreasing intervals. Last, we have symmetry. This is trying to be even. There is probably an axis of symmetry here somewhere. I see a lot of symmetry. It looks similar on the left and the right, but the y-axis does not split this evenly right down the middle. So this is not even. It's clearly not odd either. If you turned it upside down, it would look completely different. So this one is neither. It's neither even nor odd, so we'll just say neither. And that is it, my friends, for problem number 4.